Hello everyone, you're welcome back once again. My name is Victor here, and in this class we are still looking at probability, and we're still helping our students to understand the basics of probability in a more practical way. All right, what we want to do now is see on independent events. We've done a lot of classes behind on mutually exclusive events. We're now in independent events with some practical demonstration. All right, look at this. Two events are said to be independent when the occurrence of one does not in any way affect the occurrence of the other. So these are two events. These are two dice. I'm going to roll them once, and then we'll look at the sample space, and we'll see the results that can be obtained and answer some little questions around it. Why are they said to be independent? Because if I shake this now, okay, and roll it, you see, this one is 3, this one is 5. This one didn't tell this one, please try to be 3 so that I will be 5. That's why they are independent. Okay, so the occurrence of this does not in any way affect the occurrence of this. When such happens, we say that such events are said to be independent. When the occurrence of one does not in any way affect the occurrence of the other, such events are said to be independent. So if we roll 2 dice once, we can look at this case now, 5 and 2. 5 and 2. We can keep on rolling it, and we can see this is 3 and 4. So when we roll 2 dice once, the sample space A, not A, 2. 2 dice. 1 is die, 2 dice. Okay, rolled once. We have the sample space. The sample space will be, we have 1, 2, 3, 4, 5, and 6. 1, 2, 3, 4, 5, and 6. Can be 1, 1, 1, 2, 1, 3, 1, 4, 1, 5. These are possible events. 1, 6. Can be 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6. Can be 2, 1, no, 3, 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, and then 3, 6. It can be 4, 1, 4, 2, 4, 3, 4, 5. Is that where I am? No, 4, 4, 4, 4, 4, 5, and 4, 6. Can be 5, 1, 5, 2, 5, 3, 5, 4, 5, 5, 5, 6. It can be 6, 1, 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6. So these are possible events that can happen. If you keep on rolling, you will see that everything you'll be seeing here. This is 5 and 3. 5 and 3, that's occurrence. 5 and 3 is there. Okay, these are the possible things you'll be seeing. This is 4 and 5. 4 and 5 is there. 4 and 5. So these are the possible things you'll be seeing there. You'll be seeing this one like 5 and 5. Can we see 5 and 5? Look at it here. So if you roll 2 dice once, this is actually the sample space. And questions can arise from here. You can be asked to obtain the probability of a pair being factors of 12. A pair being factors of 12. There will be many here. Okay, I'm just taking that question, So a pair being factors of 12. possibly what you can have here. 1 and 1, factors of 12 is 1, 2, 3, 4, 6, and 12. So a pair being factors of 12 is not here, so we'll be stopping at 6 and 6. So the first pair will be this. Okay, I can mark something there. 1, 2, 3, 4, 5. 5, this will be out because 5 is not a factor of 12. 4 and 1, here, 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 here. 5 is here, here. 3 and 6 here. 3 and 4, 3 and 3, 3 and 2, 3 and 1. 2 and 1, 2 and 2, 2 and 3, 2 and 4, out. 2 and 6, 1 and 6, 1 and 4, 1 and... Okay, and all this thing. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. So probability of P of pair being factors of 12 will be, how many did I count there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. So we have 25 over 36. All right. The basic understanding I want to demonstrate here is the two events are independent, and because they are independent, that the probability does not affect, the probability of one occurring does not affect the probability of the other. So the sample space is here. If you count this thing, there are 36 in number. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 6 times 6 will give us 36. That's why we have this possible outcome to be 36. So, and this is the required outcome. I don't know if there is any other question. Please, there are many questions around here that one can ask. But my practical, the thing I want to demonstrate is just mutually exclusive events, and to show you how to obtain this sample space for 2 dies being those. All right, and then what again? You can have questions here. What about sum being less than 8? What about sum? What about sum being prime? These are questions. If sum means you add this and this, this will be 2. We are taking sum. This will be 1 plus 1, that is 2. This will be 3, 4, 5. So when you finish adding the sum, when you are done adding that sum, you now check the prime numbers that are in the sum. Count it over 36. That's the probability of sum being prime. You get what I'm saying? So I'm just trying to beat time, and I'm sure that the demonstration I gave here is very, very clear. If you can, in the case of that sum, you can prepare another sample space for it. Let's take this 1, 2 to 6, 1, 2 to 6, and I don't know if time is going to permit me to do that. Please, I know it's something you can do. All right, thank you so much for being there, and please give us a handshake by hitting the subscription button, the like button, and the notification button. Please share this video to someone else and bring your friends, that inform them we have a lot of work to do. We have done a lot of work already in various topics in mathematics, preparing students who are writing WAEC, NECO, and JAMB, and as the case may be, we still have a lot to do. And as you hang around with us, you're not going to regret it. Thank you for being there.